All right, welcome back. This time I would like to take a look at doing some problems. We're doing the Lewis structures. This time we're going to go ahead and we're going to do it with multiple bonds. We're going to do it with double bonds or triple bonds, stuff like that, instead of with single bonds. And I'm repeating myself from my last video, but there's multiple ways to do these. I only want you to find a way that works for you. So if you don't do it the same way I do it, that's absolutely fine. I posted some videos of other ways to do it on my website, and if you have a different way that you enjoy doing it, that you like doing it, and it works for you, go for it. Okay, so we're going to go ahead. We're going to start out with this molecule. We're going to start out with some CH2O. Okay, first thing you have to do, of course, just like last time, you have to calculate your valence electrons. Carbon is going to come to the party with 4 valence electron. Two hydrogens will have 2 valence electrons. A single oxygen will come with 6 electrons. That means that we have 12 electrons that we can go ahead and play with. We need to make everyone happy with 12 electrons. Now, remember, everyone has to be touching 8 electrons, except for hydrogen, which has to be touching 2 electrons. Next thing you do, you arrange the atoms, and you're going to fill in the electrons needed to make them happy. So I'm going to put a carbon in the middle. Ba-doom. Hydrogens, one on top, one on the side of it. Then I'm going to throw in the oxygen next door. Make them all happy. A dash stands for 2 electrons, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now that makes a problem for us. We need 14 electrons to make this molecule happy. We only have 12 electrons, so we have to do a little math here. Okay, we have to subtract them. You're going to end up with 2 extra electrons. We need to share 2 electrons. Take that number divided by 2, because there's 2 electrons in a bond, and we get 1. That means that this guy right here is going to need 1 extra electron. Okay, so what does that mean? That means that we are going to have to put in another bond. You can put your double bonds in between carbon, oxygen, nitrogen, or sulfur. Now in this case, we cannot put a bond to a hydrogen because the hydrogen only can have 2 electrons on it. We can, however, put a bond onto the oxygen. Now if you count the number of electrons on the carbon, you can see it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means that we then have to erase 2 of the electrons that were on the carbon. Take a look at the oxygen. We've got the same thing going on. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means that we can erase 2 of the electrons that's on the oxygen. Once we're done with that, once we have all those up, we can go ahead, count up exactly how many electrons we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is the number that we started out with. So it's perfect. It's good to go. On top of that, you can see all the hydrogens are touching 2 electrons. The carbon is touching 1, 2, 3, 4, 5, 6, 7, 8 electrons, so it's good to go. And the oxygen here is touching 1, 2, 3, 4, 5, 6, 7, 8 electrons, so it's good to go. So pretty much what we just did now is we made a Lewis structure. We shared some of our electrons to go ahead and make a molecule and make all the atoms happy by using only 12 electrons, only the valence electrons that was available to us. Thank you. Bye-bye.